Hello and welcome to Kite Team SCARB's final video for U of M Dearborn's Environmental Science 340 class taught by Dr. Jacob Napieralski. Our challenge this semester was to take aerial photos by kite. In particular, 4 different aerial photos. Both a high and a low oblique shot for 50 feet off the ground, and a high and low oblique shot for 100 feet off the ground. In preparing to take these aerial photos, there were 4 aspects of the challenge that we needed to focus on. The first was choosing a location. The second was determining how exactly we would use the different functions of a basic digital camera to take the pictures. Then we had to choose a kite, a particular design of kite, and research what kind of conditions were optimal for flying. Fourth, we had to build a platform for the camera, a stable platform that could adjust to fluctuations in wind to keep the camera steady.
I'm Sarah from the team Kite-Flight SCARB, and we use the Delta box style kite to use as a platform for our camera. And it seemed to be the kind of kite that other people doing aerial photography using kites were using. So we chose this style of kite.
This is our camera harness. We made it out of 2 carbon fiber sticks to give support. Use some eye hooks so we can hook 4 lines up to stabilize it. Got a piece of wood attached to the bottom that we zip tied the camera onto on both sides. That way we could turn the camera on, take verticals as well as obliques once we tie up the camera a little bit.
For the location, we needed an area that was wide open and had relatively few obstacles like power lines or trees, especially power lines. But we also needed something that we could compare the height that the kite had achieved to. For that, we chose a location called Ford Field on Michigan Avenue that happened to have a 13-story apartment building next to it that we could compare the kite height to.
One of the issues with the camera was that it did not take more than 3 consecutive pictures over a time period, so that's when we were just going to take a couple shots, and we decided we were going to have to modify it and take video instead.
The day of our flight was violently windy, chilly, and dismally overcast, which deprived us of the direct light that would have created defined shadows that we could have measured and applied trigonometry to find out the heights of relative objects, as was our original plan for determining the flying height of the camera platform. This was one of the requirements of this challenge, to take pictures from a height of 50 feet and 100 feet. But without any shadows to measure, or a pause in the erratic wind gusts long enough to take an angle of the kite string to use an equation of the tangent to find out the height, we were limited to approximating the elevation by comparing the kite's flying height to nearby landmarks. It was not quite as precise as we wanted it to be, that's for sure.
Alright, now we're going to talk about the crash. Basically our kite was rated for winds from 5 to 10 miles an hour. The Delta type is. The day we flew, unfortunately, it was a little bit more windy than that. We had
21-mile-an-hour winds with wind gusts up to 35.
So yeah, it was pretty windy that day. It was kind of hard to keep control of the kite. It didn't really work out so well. Our kite took a nosedive at with 35 miles an hour wind, so it was traveling pretty fast when it crashed. And just broke our camera pretty good.
Yeah, we had the footage from 50 feet, but when it nosedove and hit the ground, it broke the front lens, bent it in. When we sent it back up, we got a 6-minute black video for our 100 foot, so it was kind of disappointing.
My name is Swick, and I'm going to talk about a few things our group could have done differently that may have made our project run a little bit more smoothly. We should have protected our camera a little bit better than we did. We didn't use any kind of cushioning on it, and during one of our best flights, it hit the ground and actually broke, causing us to lose our video from our best flight.